remember earlier this week we talked about our laws of sines. But remember that we talked about how those predominantly work for our first two cases. So these use our law of sines. Remember that our second case was our ambiguous case. So that was the one where we can get one or no answer. Okay? However, notice that on our last two, if I'm given side, 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 or side, angle, side, right? Remember that in order to be able to set up our sine ratios, we have to have enough information to be able to solve for one of the things. The problem with side, side, side is we don't have an angle to fill in for one of our ratios. And the problem with side, angle, side is that I don't have the side opposite of the angle. Does that make sense? So we can't fully fill out any of those. So we would have two missing pieces basically, which means we can't solve. So that's why our last two cases, we have to use our law of cosines now instead. Now, an easy question for me to give you on a test is which of the following cases uses law of cosines? And I have as options angle, angle, side, angle, side, angle, side, side, angle, and side, side, side. So you would have to choose side, side, side is the one that you need to use, right? Or I could say, given this triangle, give you some information. Would we use law of cosines, law of sines, both or neither, right? So you need to know which cases use what. Does that make sense? So those will give you the easy points, but we just need to make sure that we know which cases use what, okay? So here is our law of cosines. We do have to have it memorized. I would suggest having memorized that first one, because notice that all of the other ones follow the similar pattern. The only difference is it's one side, and it always has to be the same angle inside your cosine, and then basically it's your other two angles in the other parts. Does that make sense? So if you have the first one memorized, you can just as easily fill it in with the other things. Okay? Now, your book gives you the alternative form. So notice basically all they did here was solve for cosine of A. So they subtracted b squared and c squared and then divided by a negative 2bc, which is why it flipped all of the signs on top. Okay? So if you are into memorizing formulas, go for it and memorize that one. Okay? However, I find it easier just to use your standard form, plug in all the numbers that you know, and then solve for cosine of A. Okay? Because for me, I would rather solve with numbers and not worry about having to memorize another formula. Does that make sense? But again, if you are great at memorizing formulas and you want to memorize that one too, that would be fine. So we do probably want to have those written down. Or take a picture. So on our first formula, what would happen if if A, like big A, was a 90-degree angle?
Cosine of 0.
Correct. So what happens to our formula?
No. Is set equal.
Not set equal to 0.
Oh.
Yeah, so notice if I have a squared equals b squared plus c squared minus 2bc cosine of 90, that last subtraction goes away. That's 0, which then just leaves me a squared equals b squared plus c squared, which is your Pythagorean theorem. So your Pythagorean theorem is actually just a specific case of your law of cosines. You actually already knew your law of cosines. You just didn't know that's what it was. Okay? Ready to look at an example? Alright. So, Here it says find the three angles of the triangle in figure 6.11, which is that figure. Okay. Now, since I'm given law of cosines, I'm given three sides. We know that two things. One, there has to be a triangle because they gave us three sides of a triangle. So that means I can't get no solution. They also gave us three sides of a triangle, which means that there is not a second option. Does that make sense? So that's why this is not going to be an ambiguous case, because there is a triangle, and that's the only triangle that we can make. Are we all with me there? Okay? So when we're solving for things using law of cosines, it's usually helpful to try and find the biggest angle first. Are y'all with me? How do we tell which one is the biggest angle?
You look at it.
Are our pictures always drawn accurately?
No.
Especially if you're drawing the picture, it's probably way not accurate.
It's opposite of
Yeah,
the
it's
longest
opposite of
side.
the
Correct. So your biggest angle always has to be opposite your biggest side. So even if it's not drawn super accurately, you can always check which one's my longest side. That one has to be my biggest angle as well. Okay, so for this one, which would that be? Big B. Okay, so we're solving for an angle. So like I said, if you want to go ahead and memorize that alternative form, you can. I'm going to show you how I would go ahead and solve for it just from our standard form. So remember that our standard form, because I'm solving for cosine of b, that means that I have to have my b squared with it. Does that make sense? Because that's the only one that has cosine of b. So then it's going to equal a squared plus c squared minus 2ac cosine of b. I've written that many times in my teaching career. Alright, so then from there we can fill in the information that we do know. So what is little b? 19. So I have 19 squared equals a is 8, so 8 squared plus 14 squared minus 2 times 8 times 14 cosine of b. And the reason why I said I like this way a little bit easier is because I can simplify some of these numbers first to where then we don't have as many things that we're having to subtract and divide by. Okay? So what is 19 squared? Probably not one of our ones that we know. What is it?
361.
Okay? And then what is 8 squared plus 14 squared?
260.
260. And then what is 2 times 8 times 14?
224.
224. Now, please be careful here. Can I subtract my 260 and my 224? Why not?
Because it's being multiplied by the
It's
cosine.
being multiplied by the cosine of b. And we have to take care of multiplication first before we can do our subtraction. And because b is a variable, I can't take care of the multiplication. Does that make sense? Because a lot of people just want to try and subtract those right off the bat, and we can't. So how would we solve for cosine of b?
So first you subtract 260 from both sides.
And then?
And then you divide the whole thing by negative 200.
Okay, so then that just equals cosine of b. So then how do I find just b by itself?
Inverse cosine.
Inverse cosine of all of that stuff. Now, just realize that if I went ahead and typed this into my calculator and rounded it and then put it inside of my cosine inverse, your answer is going to be slightly different because you put the rounded number in, not the entire fraction itself. Does that make sense? Which is why we round to 3 decimals, because I would not count off for you having a slight larger rounding error. So you putting 3 decimals allows me to see that you have mostly the same answer, you just rounded it differently. Does that make sense? Okay. So what do we get?
116.801.
116 point what?
801.
801, and we are in degrees. Now, the reason that we want to solve for our biggest side first, okay, is because, or our biggest angle. If that is an obtuse angle, can I have another obtuse angle? No. So if we use law of sines and get an obtuse angle, we need to subtract it from 180 degrees, and that would be the actual angle. Does that make sense? So there's not going to be two options, even though we could potentially get the wrong angle, but if you start with your largest angle, it's going to take care of that. Does that make sense? So that's why we choose to start with the largest. Alright? Questions on our steps so far? Because then from there, once I have another angle, do I have to use law of cosines again? No. From there, you could if you really wanted to. Because some people usually either prefer law of sines or law of cosines. It's just people's preference on which one you like more. I prefer law of sines, but that's just me. Because it's just easier for me to remember ratios than it is to remember the squares and the subtraction. Okay? But you could use either one. But I'm going to use law of sines. So which ratio do we have to use?
B.
B. This is the only one that we have the angle for. Okay? So I have sine of 116.801 degrees. Now we are going to have a slight larger rounding error because we did round our big B and now we're using it. So if you use just straight law of cosines again, your answer is going to be slightly different because your rounding will be a little bit different. But that's okay. And then I'm going to divide by 19. Then which angle do we want to solve for next? From here, it doesn't matter. Okay, so I would have sine of big A divided by 8. How do I solve for big A? And then?
Inverse sine.
Agreed. Okay, so what do we get for A?
$22.075.
Okay. And then, do I need to use law of sines or law of cosines to find C?
No.
No. What can we do?
Subtract both of the A and B from 180.
B. And what do we get?
I got 41.124.
What did we get?
41.124.
1, 2, 4, 3. So then those would be my 3 answers. Questions on how we set any of that up, how we plug things in, how we solve for any of those. Really, the biggest things here is one, you have to memorize your formulas. Like I have to know that it's -2 times, and you don't accidentally put a plus or a 1/2 or something like that. And then from there, you need to make sure that you're plugging things into the right spots. So like I need to plug in 19 on the other side because it's the side that's opposite big B. So you should make sure that you're plugging in correctly. From there, it's basically just algebra stuff. I'm just adding, subtracting, and then taking an inverse trig function. So the setup is usually the hardest part. Questions on any of that? No? Alright. We ready to try one on our own?
Yeah.
So which angle did we want to solve for first in this one?
How do we do
B. Again, it knocks out our potential obtuse angles, so we want to get rid of that one first. So we need to use C squared this time because that's the one that's opposite of our biggest. So then I would have A squared plus B squared minus AB cosine of big C. So C is 12. 12 squared gives me 144 equals 25 plus 64 minus, I dropped my 2. 2 times 5 times 8 times cosine of C. So what is 25 plus 64? 89. And then what is 2 times 5 times 8? 80. Okay. So then to solve for cosine of C, I would have 144 minus 89 divided by negative 80. And then I'm going to take my cosine inverse of both of those. And what do we get for C?
133.433
0.433?
434.
434?
Yeah, I just gotta remember it.
That's not what I got. I got 433. I got 133.4325.
Did you
133.34.
like this?
Yeah.
Okay. Did you round before you put into your cosine inverse?
No, mine was 133.4325. So then the 5 makes it a 3. Yep. 1.433. Yep. Means my others are wrong.
I got 432.
I got
4325.
4325, yes.
So it'd be
4325, so that last
433.
should be 433.
Okay. Because I did do the math earlier. Like I went ahead and divided 55 by negative 80, but it gave me like a finite decimal. Like it wasn't like a rounded, like it wasn't a long decimal.
Okay.
So it was like exact, so it shouldn't have been like a rounded error. Because
I would have to look at your steps, but it's okay.
55 over 80 is like negative 0.6875, so it's not like a long rounded one. Like a
I gotcha. It might have, your calculator might have rounded it. I don't know. I'd have to look.
I think it would give you more decimals.
Maybe so. Alright, so then what do I want to find next?
What are the angles?
One of my other angles. So which ratio do we have to use? C. So I would have sine of our 133.433 divided by little c was 12. Which one do we want to find next? Sure. Depending on which one you find next, okay, your decimals might be slightly different. Because if you found B next, you're rounding B and then finding A using that rounding. So again, your decimals might be slightly different, but that's okay. That's why we round to 3 decimals. Divided by 5. So I get that A equals sine inverse of sine of 133.433 degrees divided by 12 times 5, which gives us
17.612.
612 degrees. So then we're finding big B last would be 180 minus A minus C, which gives us
28.955.
and so those would be my 3 answers. Questions on any of that? Yes.
For B, because is you just subtracted it and you didn't use like a formula for it, do you write the or about equal to sign, or is it just the equal to sign?
It wouldn't be wrong to write it. I am allowed to write an equal sign because I've already written that C and A were approximations, and so I'm just using those for my formula. So I'm not technically rounding B. I'm just using already rounded numbers. Usually we only use the approximation if what we're plugging in there, that's what we're rounding.
Okay.
Does that make sense? But it's not necessarily, it wouldn't be wrong to put an approximation sign there.
Will we get points off if we didn't do this quickly on those others?
The approximation symbols? No. Because most of the time my instructions are going to say round to the nearest whatever, so I know that you're rounding. Usually it's just done to tell your reader that you're rounding. Does that make sense? Other questions? Those are good. Alright, so on both of these examples we were solving for what?
All three angles.
Angles, okay? We could also be given something, so this is side angle side. So notice, can I use law of sines to solve for A? Little a. Because that's the one that I know the angle for, right? But the problem is that I don't know my other two angles, so I can't set up an equal to ratio that's filled in, right? Okay. I also can't solve for B or C
Right.
because notice that I don't have side A. So we have to use our law of cosines, but this time we're solving for side A first. So we want to use our A squared equals B squared plus C squared minus 2BC cosine of big A. So B is 9, so 9 squared gives us 81, plus C squared is 144, minus 2 times 9 times 12, cosine of 25 degrees. So when we're solving for a side first, it's actually a little bit easier because we don't have to do as much subtracting and things like that. Okay, so I have A squared. What is 81 plus 144?
225.
Agreed? And then what is 2 times 9 times 12?
216.
Cosine of 25. Again, can I subtract my 225 and my 216?
That's illegal.
It's illegal? Yes.
Math
The math cops are going to come and hunt you down. Okay. So how do I solve for A then?
Yeah, square root.
Square root it. So I have 225 minus 216 cosine of 25. What do we technically have to put when we take square roots? Plus or minus. I have a triangle though. That's the side of a triangle. Can the side of a triangle be negative?
No.
No. So we have to choose the positive one. So then
Do
we'll,
we need to put that then?
no. I'm just putting it to show that that's technically what we had to do there. We're just choosing the positive one. So
Choosing to be positive.
yes. Hopefully we all choose. So what do we get from that?
Got 5.407 meters.
We all agree? Alright. So then from there, because I have all three sides, we can either choose. Again, you could use law of cosines because I have all three sides to solve for your other two angles. Okay? Or we can now use law of sines because I now know both angle A and side A. So we can use that ratio. So if we use that ratio, again we're solving for angles, so we want our sine to be on top. So I would have sine of 25 divided by, what do we get? 5.407. Which one do we want to solve for next?
D.
Sure. Sine of big B divided by 9. So if we solve for big B, what do we get? Sine inverse of all of that jazz. And And what do we get for B?
No, 44.75.
44 point what?
705 degrees.
And then lastly, what do we need to find?
C.
C. Do I need to use law of sines and law of cosines?
Nope.
No.
No.
Minus, because we know A and B now. So we can just subtract from 180, and what do we get?
110.295.
Now, on your test, most of the time, I will just ask you for one of these things,
Oh, good.
because it would just take a long time to find all of them. However, we now know how to find all of them if we needed to. However, the one thing I could do is ask you,
It's like not the immediate.
well, yeah, so like I could ask you to find angle B, right? But could angle B be the first thing that I solve for? No, because I don't have enough information. So I would have to solve for side A first in order to get angle B. Does that make sense? Okay. And that is another, so remember that I said that you do have bonus on your project? And part of the bonus is either one, to use the ambiguous case for your law of sines, or the second one is to have multiple unknowns. So the way that you could set up a word problem like that is to ask your reader to find this angle, but in order to find this angle, they would first have to find this side. Does that make sense? So that would give them multiple unknowns that they're having to solve for.
So the project is basically just making a word problem.
Correct.
Does it have to be like based on like real world data or something?
No, not necessarily. It does have to make sense though. So like, you couldn't, if you're using like say planets, we couldn't say that we are 5 miles away from the sun. You know what I mean? So you at least have to make it 5 million miles. You know what I mean? Like the
Within the realm of possibility.
correct. Yes. The biggest thing there is that you are gonna have to write it as a word problem. We're gonna go over this more tomorrow. Like you couldn't. This is not a word problem. Like this could not be your project.
So we're writing a word problem for a triangle.
You're having to write a story, so someone's gonna have to be able to draw the triangle based upon the story that you tell them.
So you can't like immediately say that you're triangle. You have to.
I got mine.
Correct.
Mine's gonna be
Like I couldn't just say, given the, like pretending that so and so is walking this on this triangle. No, like you have to describe so and so is walking this degrees in this direction, this amount of distance, so that your reader could then draw the diagram themselves. But again, we're going to go over more of that tomorrow. So, like our law of sines, we got a new area formula. If we're given 3 sides instead, we also have a new area formula for that, and that's specifically called Heron's area formula. Again, in mathematics, if you create a formula, you get it named after you. And also remember, on your test, I would give you this formula if you need to use it. So we just need to know how to use it. We don't have to necessarily memorize it. The biggest thing here is notice that there are S's in there, and it defines S to be A plus B plus C divided by 2. So you kind of have to find S first, and then you can plug in the other stuff. Ready to look at an example? No. Okay, so since finding the area of a triangle having sides A equals 43, B equals 53, and C equals 72. Now, really, in this case, our formula is not dependent upon our side lengths. So if it makes you happy, you can draw a picture But since we're not having to set up ratios or anything like that, we don't have to worry about making sure the correct angle is the correct side or anything like that. But that's what your triangle would look like. So what did I say we need to find first? S. So S is going to be 53 plus 43 plus 72 divided by 2, which is what?
84.
Okay, so then we can plug into our area formula that we had on the previous page. So we have the square root of S times S minus B, or S minus A, times S minus B, times S minus C. Agreed? So we have 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. So what is 84 minus 43?
31.
41. 84 minus 53? 31. 84 minus 72?
12.
Whoa.
Just blink all that and you'll count
You could. I would be careful about plugging it in on that second step just because that's a lot of parentheses that you gotta be careful about. If you did it from here though, the 84 times 41 times 31 times 12, that would probably be fine. So like I said, you can, just you have to be really careful about those parentheses. Okay? So then what do we get that our area is?
1,131.
1,100
Yes.
and
31.
31.
887.
31 point what?
887.
887, and we are in meters
Square.
squared. Why do I get meters squared when I'm multiplying lots of things together? Yeah, well, why?
Because you're multiplying meters together. And then meters times
How many meters am I multiplying together though?
many of them.
What is 84? Is 84 going to be in meters as well?
No.
Each of these is in meters, and
Oh,
then I'm
square
just
root.
dividing by 2, so that would also be in meters, right? So 1, 2, 3, 4 meters,
Okay.
but then I'm taking the square root of my unit as well, which is why we get meters squared instead. So remember your units, follow the same math rules as all your other stuff. Alright, last question. So the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet as shown in the figure. The pitcher's mound is not halfway between the home plate. That's really important, okay? How far is the pitcher's mound from first base? So we're trying to find H, which is what they give us, yeah? Why do they tell us that it's not halfway?
The picture can almost look like it's half.
Picture slightly looks like that, but we don't necessarily know that, right? And so that's why I'm saying don't assume things that it doesn't tell you, which some of y'all have a bad tendency of doing.
What is it?
What?
Oh, it doesn't say it.
It says that it's not halfway, because if it was halfway, it would create a right.
No, I mean like with the 45-degree angle. Is that just on there and it doesn't say in the question?
Correct. Which, like on your project, you wouldn't be able to do. You would have to describe that angle.
Are you supposed to provide a picture?
Well, I mean, as a part of it, you will be drawing the picture to go along with it, but basically, you have to be able to draw that picture from your words. Okay, so if I want to set this up, what are we looking for?
H.
H, which is a side. So I would have H squared equals, because it's just going to be my opposite sides, it's going to be F squared plus P squared. So F squared plus P squared minus 2FP cosine of big H. So again, the letters aren't necessarily what's important, it's the basically pattern that we use. So F is 43, so we would have 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45 degrees. So what is 43 squared? Plus 60 squared. So I put all that. 43 squared plus 60 squared gives us
5,449.
449.
Yes.
Okay, and then 2 times 43 times 60. Should be like 120 times 43. No,
I got 5,160.
160.
Yeah.
Okay, and then how would I solve for h? Take the square root of all of that, and then plug that into your calculator.
Oh, you're doing that
42.43.
42.4030,
30.
and we are in feet this time. That was why they said not,
Yeah.
because you cannot assume it's a right triangle because it is not halfway. That's specifically why they said that.
Did I do that after?
Questions on that? So verbatim that.